Hi class, today we're going to be discussing understanding research and the scientific method. It is going to be really important as we move forward in our nutrition class that we have a clear understanding of how we've derived the suggestions and the recommendations that we have, looking at scientific studies and trying to determine, are those studies reliable? Should we be looking at those studies to give us guidance on how we need to eat? And so we are going to talk about the steps in that process. So here we get to the scientific method. And ultimately what we do is, we get to a real world problem and we say, we want to know about this. Let's take obesity. And we look at all the related research on obesity and we look at the different theories and we decide, well, if we're going to test one of our theories, what method are we going to use to test that? Now, your textbook in chapter 1 goes over a few different methods. Really common in nutrition is we look at case studies, we look at experimental designs, we look at correlational designs, and we look at epidemiological studies. And all of these different types of studies give us a way to study the population in which we either manipulate a part of that population, for example, in an experimental study, or we study a population over a period of time because we see large changes within that population. A really good example of that is an epidemiological study, which is how we've derived much of our belief system on the Mediterranean diet by studying the Mediterranean populations and their susceptibility to things like cardiovascular disease, obesity, type 2 diabetes, etc. So ultimately we design our study and then we collect data. And so in order to collect data, we likely we'll get a sample of our population. And what that means is if we're taking a sample of our population, it has to be a wide varied sample. So we are going to make sure that we have the same amount of men and women. We're going to make sure that all ethnicities are represented. We're going to make sure all ages are represented, because as much as humans or Homo sapiens, we're all very quite different. And so the way food interacts with the physiology in one human being is going to be really different than in another human being. And so we want to make sure that we have a nice sample of that population and we're going to collect that data. And then we're going to evaluate those results. This is very important when we discuss the research in nutrition, because this is where basically science can lie to us. And when we see publications and when we see advertisements on TV that say, 20% of participants lost weight. Well, what we know is by saying 20%, they actually can't tell us that a large amount did actually lose weight. And so we look at statistics, and a lot of the reading that you have is also looking at statistics. And so we want to know that there was a very, very marginal chance of error within that research study. And so that's what we do. We look at those statistics. And ultimately what we're looking for is we're looking for a p-value of 0.01 or 0.05. And what those mean is that we are either 95% sure or 99% sure that whatever experiment that we did, whatever thing we manipulated, the outcome that we saw was the result of that experiment. We're saying that there is no margin of error. We're 99% sure. We're 95% sure. And then we discuss that and we reach a conclusion. But at that point, we take this information and say, we have to rework it. We have to do this again. We need to test another sample of another population. We need to continue to evaluate this. This is why research is always ongoing. And that brings us to the next point of validity and reliability. So like I said, just because one study says so, we have to keep going and keep going and keep going. Because ultimately, the premise of research is going to fall within these two things. Was that research study valid, and was it reliable? Validity means it's actually measuring what it says it's measuring. For example, let's take HCG, which is a hormone that women produce when they're pregnant. Popular diet pill. And you eat 500 calories and you take this pill. So participants lose weight when this occurs. And they say it's the result of taking that HCG pill. But then let's look at validity with that. Now, are the participants losing weight because of a pill, or are the participants losing weight because they're only eating 500 calories a day? So what we see in that type of research study is that's not valid because it's not actually measuring the pill, because two things are happening at the same time. Okay, so that's when we say validity, we're saying that we are measuring what we think we're measuring, and therefore we can hold responsible what we think needs to be held responsible. Ultimately, if we're using that past example, that we know it was the pill that resulted in weight loss, and it was not the deficit of calories when someone's only eating 500 calories a day that was resulting in weight loss. Now let's get to reliability. Reliability means regardless of the experimenter, regardless of the situation, that result is reliable and then that we can replicate it multiple times over. And this actually fails quite a bit. A really good example of this is the studies in dairy. And so I don't know if you remember, about 10 years ago, our dairy corporation's new campaign was "Dairy helps you lose weight." The reason that came out as an advertisement is there was a study of about 1,000 participants, and those participants who had dairy as a part of their diet, everyone was obese in the study, lost a significant amount of more weight than the people who did not eat dairy. And therefore, dairy jumped right on board and said, dairy helps you lose weight. You got to have dairy be a part of your diet. They were never able to replicate that study. So what that shows, and this is the flaw in science, just because we found it one time, even if we were 99% sure, sometimes we're not right. And this is why we repeat our studies. And this is what it means to be reliable. It means that we can redo this same study over and over again, and we can get that same result. So in nutrition, this is where a lot of the tricks come in, because we'll have one study, dairy example is a perfect one, and we had 3 years worth of ad campaigns on the dairy. And even today, you'll still hear a low-fat dairy diet is really important as far as a diet for maintaining a healthy weight. And there's absolutely no scientific evidence to support that whatsoever. But once one study showed that, it became grasped onto. Okay. So let's kind of look at these definitions a little bit closer. If something is valid, it doesn't mean it's correct. And a good example of this, for example, is an IQ test. If this new test delivers scores for a candidate, 87, 65, and 143, and 102, the test may not be reliable or valid because if it's delivering multitude of scores for one person, then it has neither. Now, if it delivers a score of 100, but the candidate's real IQ is 120, the test is reliable because it's over-delivering or under-delivering every time, but it's not valid. A really good example of this in fitness would be a bioelectrical impedance scale. If you've ever stepped on one of those scales that send the little rays up through your feet, well, on average, those will underrepresent your fat mass by 3 to 5%. And so, or let's just take a scale in general. If your scale always overweighs you 5 extra pounds, it's valid. It'll always be 5 extra pounds over. Is it reliable? No, because it's not actually telling you the right weight. Okay. So as we move forward in looking at claims that we are going to be evaluating within nutrition, these are some of the questions we're going to ask ourselves. And this is some of what your reading is bringing back to the forefront. Was the research design solid? Did it follow the scientific method? Are the findings validated? Do they measure what they say they're going to measure? Are there other things in that study that could confound it? For example, many of you have heard that sugar-free foods, like diet soda, cause you to gain weight. And there have been a couple of research studies to show this. What they never actually held constant, and what I mean by held constant is put that into the measuring category, is what the participants ate besides a sugar-free soda. And what they actually found, and later re-evaluating these studies that said people who drink diet soda gain more weight than people who don't, is that people who are drinking diet soda felt like they had earned a freebie. And so they were more inclined to eat junk food at other parts of the day, and they ate a higher amount of junk food than people who didn't drink soda at all. And so it had nothing to actually do with the diet soda and had everything to do with the way that that participant ate throughout the day. So as we're reading research studies, these are the types of things that we're going to be looking for. And then we're going to be looking for that reliability. Can we find another study to support the assertion that the scientists are making within this first study? And so for a lot of the data that we're going to look at, we are going to sit back and we are going to try to find complementing studies or opposing studies. Unfortunately, some of the worst things that happen in science is we don't hear about what doesn't work. When people don't find what they're looking for, they don't tell anybody. And sometimes not finding what you're looking for can be as important as finding what you are looking for. And so we will be evaluating research from those dimensions. And this really nicely correlates with your chapter 1 on evaluating really looking at experimental designs. In addition, as you go into your readings and healthy choices, we'll talk more about understanding the statistics behind it.